Okay, now the thing which is I want to do next is actually I want to do what we call a separable differential equation. So we're going to solve differential equation, but this time I want them to be what we call is separable. So hopefully we're going to focus on the word separable. Separable meaning that you can separate the variable. So if we actually were going to separate the variable, uh, so I'm going to go ahead and look at the first equation right here. We have x squared plus 1 times dy over dx, and that's equal to x times y. Now, when I saw this one, if we can separate them, that's called separation of variable. So we're going to get all y's on one side and all x on one side. So we're going to actually have over here, let's see how we can write it. We're going to write x squared plus 1 dy is equal x times y. Now, what happened over here, I would really like to divide both sides by x divided by squared plus 1, and that is dx, and that's right here. I could actually take this y and divide the other side by y, so this way we can eliminate the y. Then we have dy over y, and that's equal to x dx over x squared plus 1. Now, let's go ahead and see. Now, when we integrate this one, so we're going to integrate this side and we'll integrate this side. So we'll integrate this one with respect to y and this one with respect to x. So the integration 1 over y is called ln of absolute value of the y. Now, for the other side, we're going to say x squared plus 1 equal to u. Therefore, your du will be equal to x dx. Therefore, dx will be equal du over 2x. So then we already have x, but we need a half. So it's going to be a half. This is just basically du over u. Well, the integration of du over u is equal natural log of absolute value of u, but u is, keep in mind what's u. U is this. U is x squared plus 1. And now when we finish integration, we add plus the c. To get rid of, because we're supposed to solve for y, therefore we're going to apply e to both sides of the equation. So then we will have y on this side, and that's equal to, because e and ln they cancel each other, equal half can always go on the top right here. Half can travel all the way on the top. So it's going to be e to the n of x squared plus 1 to the power half times e to the c. You have to be sure that when you have e to the a plus b, that's equal e to the a times e to the c. So now, then what we will have, e and ln cancel each other, so y is equal equal x squared plus 1 to a half power times e to the c. So that's actually the equation we should be able to write if we want to, write our final solution. Or we can say times c in the front, so because that's the general solution in the front. And we're able to actually find what is the idea. See, some people, they leave it like x squared, or some people, they write it y is equal the square root of x squared plus 1. And this e to the c is just a c. So we can put a c in the front if we want to. Or, yeah. Okay, now what I want to do, I want now to have another equation which is also separable. So this way we can see how it is, how the engine can be written, so we can actually try to see if we can separate the variable before we go any further. Let's look at the second example. And the second example goes as follow. We're going to have, let's see, I want to have actually a nicer one to deal with. Okay, okay, let's take this one, see how this one, and if we can separate it or not. So we have dy over dx, so this is example 2, dy over dx, that's plus e to the x times x plus y, and that's equal to 0. That's a homogeneous equation, by the way. But I want to do it by separation of variable, meaning this is dy over dx, and that's equal negative e to the x times e to the y. To the other side, and I spread out the x from the y, meaning I'm going to have dy over e to the y right here, and this one is going to be e to the negative x times the dx. So what we did is we separate them. The minute we separate them, we'll go ahead and integrate. Keep in mind the dy and the dx is always has to be in the numerator. So now I'm going to write this one as e to the negative y dy, and that's equal negative e to the x dx. So now what? What's the integration of e to the y? E to the y is e to the y, but since it's negative, you put the negative in the front, which equal to, this is negative e to the x, e to the x plus c. We don't have e to the x is e to the x. Well, negative, we can actually divide. Let's see how we can actually handle this one, because first we divide everything by negative. So e to the negative y equal e to the x minus c. Minus c or plus c is the same thing, is no different. It's not going to make any different for us. No, the way now we need to simplify it a little bit further. We need to know like how would we integrate how we will integrate this. So now I want to solve for y, not e to the y. That's what one of the things we need to make sure that we can do it. So we'll go ahead and apply ln to both sides. Ln of e to the negative y equal ln of e to the x minus c. Well, ln and e cancel each other, so therefore we have negative y equal to the natural log of e to the x minus c. We multiply by negative, therefore y is equal to negative the natural log of e to the x minus c. Notice we just put the negative in the front, and that's basically it done. So what we did is we found the general solution by separation of the variable from one to another. If we're able to actually separate the variable, then the equation will become easy to do. Go ahead and stop. Do 2. That's good.